In this video, we'll dive deep into the world of BLoC by exploring the BLoC state management tool as well as the BLoC pattern. We'll start by adding state management to the default counter app using both Cubit and BLoC. After getting a rough idea of both the tools, we'll delve into Cubits with a to-do list app and explore BLoC further by adding form validation to a login form app. Finally, we'll implement the BLoC pattern in the weather app. By the end, you'll have a clear understanding of Cubit, BLoC, the BLoC pattern, and the package capabilities. The prerequisite for this video is the basics of Dart, Flutter, and Provider. If you're not already familiar with it, you can watch the 20-hour free tutorial present on the channel. Subscribe because the button lights up when I say it. Now, let's get into the video. So we're going to start off with the counter app. So what I'm going to do first is go to the lib folder, go to the main.dart file, and first I want to remove all the comments, so I can just press Command F. Then I can do // dot asterisk. Then I can click on this particular icon, which is use regular expression. After that, I can click over here, which is toggle replace. And then I can click on this button, which will replace all the comments with an empty space. After that, I can just press Command S, which will format the entire document for me. And now all the comments are out of my file. The next thing I want to do is just take this home page and put it in a separate file of its own. So I can just create a new file in home_page.dart. Then I can import material.dart package and paste this code in. So I have my home page here. Now the final thing is just to import this home page. Now I'm not going to edit any code inside of this right now. We're not going to add any extra features or anything else to this counter app until we get to implementing the BLoC section in this code. So let's install BLoC. To install BLoC, let's go to pub.dev and then we can search for the BLoC package. Now, when we search for the BLoC package, we get two results that we might use, BLoC and Flutter Bloc. The BLoC package contains things that you will use in your BLoC layer, like the BLoC class. This isn't necessarily Flutter dependent, it is just the logic architecture of your app. So in theory, you can also use this particular package in your Dart apps only. Flutter Bloc, on the other hand, contains elements that you can use in your UI layer. It includes widgets like BlocProvider, BlocBuilder that we're going to get into that will make it easy for us to implement the BLoC state management and display the data on the screen. And Flutter Bloc contains the BLoC package, so we don't have to worry about it either. So we can just copy it and go to the pubspec.yaml file. In the dependencies, I can just add the Flutter Bloc package. After that is done, we are all set to manage state using BLoC. Now, there are two approaches you can take while managing state in BLoC. The first approach is by using BLoC state management, and the other one is by using Cubit. Now, there are advantages and disadvantages to both of them, which we'll discuss in great detail. But right now, I'm going to implement both of them in this counter app so that you get a rough idea of what the difference really is, and then we'll dive deeper into each of them. So right now, first I'm just going to start off by creating a Cubit folder. First, we'll implement state management using Cubit. So I've created my Cubit folder. Inside of it, I'm going to create another file which is going to be called counter_cubit.dart. And I like this naming convention because the first part of this name, counter, suggests what my state is going to be, what state am I managing inside of this Cubit, and _Cubit tells me that, well, it's a Cubit. It's not a BLoC package, like it's not using BLoC over here, it's using Cubit. So that's pretty helpful for me as well. I can click on enter, and now the first thing we have to do over here is create a counter Cubit class. But just creating a class isn't enough. When we create a class, well, we've just created a class. We cannot manage state inside of this class. To get started with state management using Cubit, we first need to extend it to Cubit, which comes from the Flutter Bloc package. So make sure you have imported this at the top, and after that you can extend it, which will give you another error. And the error says that the superclass Cubit dynamic doesn't have a 0 argument constructor. Try declaring a zero argument constructor in Cubit dynamic or declaring a constructor in counter Cubit that explicitly invokes a constructor in Cubit dynamic. What does this even mean? It basically means that if we go to Cubit's source code, so I press command and click over here, I'll go into the source code of Cubit.dart, well, basically the block package code. And here I can see it is an abstract class which extends block base and it has a constructor requirement. And this is what the error is telling us. If we hover over this, it says Cubit doesn't have a zero argument constructor. That means it has a constructor and its value needs to be passed from the child class to the parent class. So we need to pass in the value from counter Cubit to this Cubit. And what is the value that we need to pass? Well, it's mentioned over here. We will have to pass in the initial state of our counter Cubit. So we are left with two questions after this. The first question is, what is our initial state going to be? And what does initial state even mean in this context? And the second question is, how do we pass the initial state from the counter Cubit class to the Cubit class? Let's answer both of them. So what are we managing over here? We're managing the counter variable. So whenever I click on this increment button, it increments by 1, right? This is the state that I'm managing over here. So what is my initial state going to be? Well, if I refresh, my initial state is 0. Because whenever I refresh the app, I want my counter to start from 0. So that's what my initial state is. Whenever the app restarts, I want it to continue with 0. And the second question is, how do I pass the value from counter Cubit to Cubit? To do that, we can just create a constructor. We have counter Cubit over here, and then we can use a colon, then call super, and then we can pass in the value. And this is how the error is gone, and we have passed the initial state to our Cubit class. And this state can be literally anything. You can pass in a class, you can pass in string, you can pass to it any data type you want. So we have created a constructor, and then we are calling super, which calls the super class, which is the Cubit class, and passes the value to its constructor. So now that this is created, I just want to see the initial state showing up on my screen. What I'm going to do is replace all of the state management logic that's present in our code currently. We'll replace that with BLoC state management. And to be more specific, I'm going to replace it with the Cubit logic. So first of all, I'm just going to remove the increment counter and counter variable. I'm also going to remove this increment counter function call over here and just going to put an empty function. We're going to change this later on, but for now, this is just fine. We first want to display the initial state on the screen. So let's figure out how to do that. So what I can do over here is just create an instance of the counter Cubit class. So I can just have, let's say, counter, which is equal to counter Cubit. And if I do that, this would be an instance of the counter Cubit class, and that's good. But if I just put a full stop after this, I get all of these options. Where are all these options coming from if I never implemented any of these attributes in my class? Well, they're obviously coming from the Cubit. If I just remove this call and just put it like this and come over here, we wouldn't get any of those suggestions. They're all coming from the Cubit class, which helps us to manage the state. So from all of these values, the value that I need is state. State would give me the value of counter, and I can just take that and put it over here. And with that, I'm able to display the state of my app. But there's one problem over here, and that is this shows up as dynamic counter. And we know that we should refrain from using dynamic in our app. So how can I make sure that this is given as int? To do that, we can just go to the counter Cubit class, and over here, we are extending to Cubit, and we can just pass a generic type over here, which is of the type int. Once we do that, this counter would become the type of int. And even over here, if I just try to pass a string to my super class, it wouldn't accept that because the argument type string cannot be assigned to the parameter type int. since we've mentioned the type over here, we've made our code a little better than before. So we don't have to use dynamic anymore, and we know that the state of this Cubit class is going to be an integer. And that's what we get. Now I can just restart the app and there it shows up. It shows up 0. It seems like nothing has changed, but if I click on the increment button, the value doesn't get updated. And that's because I've not created any function that would increment the value of the counter Cubit state over here. So I need to figure out a way to do that. So I can just go to the counter Cubit class, and inside of here, I can create a function that would increment the value of the state and notify all the listeners that, hey, the value has been updated. So I can just create a function over here, which is called increment. And now inside of this, I just want to increment the value by 1. So I need to take the state and update it by 1. So if I just do state is equal to state plus 1, it would work, but this doesn't work because state is not a setter. It is not a variable that can be changed. It is a getter. A getter cannot be changed. So I cannot use this, and because of this, another function is created which is emit. Emit updates the state to the provided state. As you can see over here, emit updates the state to the provided state. What this means is emit updates the state of this class to the state that is provided in this parameter. So if I just pass emit state plus 1, it would update the state to state plus 1, and it would notify all the listeners listening to this counter Cubit that, hey, the state has changed, please update your UI. So now that our increment function is done, I can just go to the home page, and over here, I can create an onPressed, which would be counter Cubit. So I can just take counter Cubit dot increment. And if I just do this, I should hope that it starts working, right? However, when I click over here, the state doesn't get updated. What's the problem? To understand the difference, I can just print over here before, and then I can just pass in the state over here, and I can just say after. So here I'm just checking before the emit is called, what is the state, and after emit is called, what is the state. If the state changes, that means the increment function is called correctly, the state is being updated properly, there's problem somewhere else. So I can just restart my app, I can click on the increment button, and I can open my terminal to see that before it is 0 and after it is 1. So the problem isn't in our Cubit, it's all good. I can just remove this again. I can close my counter Cubit. So what could the problem be? The issue is that I've created 2 instances of counter Cubit over here. So what's happening is I'm creating one instance of counter Cubit, I'm creating another instance of counter Cubit, and in one instance, I'm calling the increment function and its state is updating by 1. So the state over here becomes 1, but the state on the other Cubit is still 0, which I'm using to display on the screen. So this 0 is being displayed on the screen instead of this being displayed. So I need to eliminate the usage of 2 qubits. I just need to use 1 qubit to handle this. So what I can do is just create something known as counter qubit over here, which will hold the instance of counter qubit class, and then just call it final counter is equal to counter qubit dot state, and we get an error over here. And the error is there because we cannot access counter qubit in an initializer over here. So I can just take this from here and put it over here, right? That should be fine. And then I can go down and I can use the same counter qubit to increment as well. So counter qubit dot increment comes over here, and this looks good. So it should work right now. And if I click on it, it still doesn't work. So the problem isn't in counter qubit instances being more than 1 now. The problem is in this particular line now. And the problem is that counter qubit.state gives us the state of the app, and it's a one-time thing. It gives us the current state of the counter qubit that, hey, right now I went inside and saw that the state of this entire class is 0. So I can just give that value to counter. And now counter is 0, so it will display 0. But when the button is called, the state updates inside of it, but it doesn't notify the counter class that, hey, the value has changed over here. It doesn't say that to this particular line. To prove what I'm saying, convert this arrow function to a block body and I can just call setState. If I do this, I'll restart my app and click over here. You see, it starts working. It starts working because I've incremented the counter qubit over here. So the value of the state is now 1. And then I call setState, which triggers a rebuild of this build function. So this counter is called again, and because of that, counterQubit.state again goes to the counterQubit class and asks, hey, what is the state over here? Okay, so the state is 1. I can just display 1 right now. But we don't want to use setState inside of this. How can we do it without setState? I said that emit function updates the state and notifies all the listeners about the updated state. We're not listening to the state yet. We're just getting a one-time value from it using this line. If we want to listen to the state, what we can use is a widget provided by BLoC, and that is the BlocBuilder widget. So what I can do is wrap this entire scaffold if I want. I can press Ctrl+Shift+R to get this dialog box, and I can just wrap it with the builder, which would be BlocBuilder. And obviously, don't forget to import the Flutter Bloc library at the top. After that, I would get access to the builder function, and the builder function gives us context and some value. The value it is giving here is the counter value. But along with that, we also need to pass in a block. So I can just take in a block over here and I can pass my counter qubit instance right over here, and it would accept that. Why would it accept block in counter qubit space? Because if we just go to the implementation of this BlocBuilder, we'll see that the block, which is b value, should extend state streamable. And if we go to qubit, it extends block base, and block base extends state streamable source, which implements state streamable. So we can use counter qubit instead of block over here. And what this BlocBuilder does is basically based on this counter qubit, it will give us the value of the counter. And even over here, we can mention that the type is counter qubit and integer. If we don't mention it, the value of the counter will remain an object. It doesn't know yet what the value of the counter is. So we need to specify it over here that the block is counter qubit and the state value is integer. So now this is an integer, and there we go. Now if I restart my app and increment this, you see it starts working, and that works without using setState in the entire code. So just to recap, BlocBuilder is basically a widget that Flutter Bloc provides to us, and it requires 2 arguments, block, which is not a required argument, and we'll talk more about why this isn't a required argument, why it's an optional value, and the required argument actually is builder. And whenever the state of this block changes, the builder will be run again. So this entire builder will be called again as soon as the state inside of this counter qubit changes. So I think you can understand a little bit of problem in terms of optimization over here. If the state inside of this counter qubit changes, this entire scaffold is rebuilt. But this entire scaffold doesn't have to rebuild whenever the state of the counter qubit changes. Only this text has to be rebuilt. So we can modify this code a little bit to optimize the app further. Instead of rebuilding this entire screen, we can just rebuild this particular text widget whenever the state changes. So I can just remove this entire BlocBuilder from here. Now we're back to the normal app, and I'm just going to wrap it around the text. So we just have a BlocBuilder over here, and I can just tweak it a little bit to return a text over here. And that's all. So now our improvement only modifies or rebuilds this text widget whenever the state changes instead of this entire scaffold. So that's a good improvement, and BlocBuilder makes that possible. So if I restart, just to prove it to you, everything works as before. So just to get a little bit of practice, I can just wrap this floating action button with a column, and I can just create another floating action button which is of decrement. And we can just see how we could implement decrement in counter Cubit. So I can just use icons.minimize, let's say, yep, and I can just save it. So we have our two buttons over here. Just to get the layout right, I can just use main axis alignment as main axis alignment.end, and both the buttons are over here. Now whenever I click over here, I want to decrement instead of increment. I challenge you to try this on your own and see if you're able to do it. So pause the video and try it on your own. I'll just go to counter Cubit and start working on it. So I can just use void decrement, and I can just do emit state -1. That's what my ultimate state is going to be, right? Whatever value I have, I just want it to be -1. And after that, I can call the decrement function over here. And now whenever I decrease, it would decrease. And whenever I click on increase, it increases. That's great. But let's go a little bit advanced in this. What if I want it to stop before 0? So if I hit minus right now, it shouldn't go to -1. It should just stay at 0. And when I increment, it can go up till infinity. So my bounds are from 0 to infinity. How do I implement this logic? Pretty simple, right? I can just go to my decrement function. I can just check over here. If state is equal to 0, then I don't want to do anything. So I can just return over here. So if state becomes 0, I want to return so that I don't call this function. And because of this, I would never go below 0. Now if I run this, I'll call decrement, it doesn't decrement, but if I click on increment and decrement, it works up till 0. And that's the logic. The point of doing this was just to show you how cleaner code can be using Cubit. All your state logic comes in one particular class, and all of your logic stays inside of this function. Nothing is thrown into the UI. All your logic stays in counter Cubit, and that's the big advantages these state management solutions offer. Another important thing that I wanted to tell you is I cannot call counter Cubit.emit outside of this counter Cubit class. Even though it allows me to, it does add a warning saying the member emit can only be used within instance members of subclasses of whatever is written over here. Emit is a protected function. Since it's a protected function, I cannot use it outside of my Cubit. I cannot use it outside of this counter Cubit class. I should be using in this class itself. So that's one thing to keep in mind. Another question I have for you is, what if we had two pages? On the first page, we only saw this and we didn't have any increment decrement functions. And on another page, we had the increment and decrement functions or increment and decrement buttons. How would we do it then? Let's go ahead and try it out. So I can just call this page, for a lack of better naming skills, I can just do increment decrement page.dart. I can import material.dart, and I can create, let's say, a stateless widget, which would be increment decrement page, right? And now I can just create a scaffold, and we're not going to focus on the UI skills right now. So I'm just going to take this floating action button from the home page and put it over here. So I can just take this floating action button and put it over here. There we go. So now I need access to this counter Cubit instance. Now I can get it through the constructor, but I'm planning to use GoRouter for routing. To route from this page to the other page where my increment decrement page lies, I'm planning to use GoRouter there. I cannot pass like a counter Cubit instance from there. So how will I be able to increment the function? If I just create another instance of counter Cubit class, it would just be the same thing we did in the beginning, and it would not work. We would be creating two separate instances of counter Cubit class. So how can I pass this counter Cubit? And that's where you would think that provider would come in handy, right? We could just use provider to provide the instance of this counterCubit class once so that we could access it from anywhere in our app. So if we had provider with us, we could just go to the main.dart file. I would wrap my material app with the provider widget. I would provide the instance of this counterCubit class, and then I could access that counterCubit instance from anywhere inside my app. But unfortunately, we don't have provider with us. Or do we? Well, we do. BLoC behind the scenes uses provider to provide instances of BLoC. And it gives us access to one nice widget with that. If I just press Ctrl+Shift+R again and wrap it with a widget, I have access to one widget which is known as BlocProvider. And if you see, this comes from the Flutter Bloc package only. We have not installed provider package. BLoC package gives us access to BlocProvider, which we can use to provide instance of BLoC from one page to another. So how this would work is we would just create BlocProvider over here. We have to pass in a create argument which would accept BLoC, Cubit, anything you want. I can just pass in my counterCubit instance over here. And we also need to pass this as a function. So we can just do this. And that's it. Now we can access the counterCubit instance from anywhere in our app, just like we would using provider. So this is kind of like provider, but when we use BlocProvider, we can only pass blocks. We cannot pass normal classes. They need to be of the type state streamable source. Now I can just go to my home page, and over here, instead of creating a new counterCubit instance, I can delete it. And instead use the counterCubit that we get from the BlocProvider. I can just use final counterCubit is equal to BlocProvider. It's the same syntax as provider. We would use provider.offContext to get access to it, but here we would just do BlocProvider.offContext, and here we need to pass the type of the block. So the block I'm using is counterCubit, and then we have our counterCubit with us. And now, because of this, we don't even need a stateful widget. We can just be satisfied with a stateless widget. And instead of using widget.title, we would be using title, and that's all. So this should work. And now I can do the same thing over here in my increment decrement page. I can just take this, go to the increment decrement page, paste it over here. Of course, make sure you import all of the things. And now you can just take this counterCubit to increment, decrement, and yeah, that's how we'll be able to work. Now just to test it out, I'm just going to go to the home page, and here let's create a floating action button again, but this time the on pressed is going to be, well, navigation, and the child is going to be an icon that basically says that we want to navigate. I can just use navigate next. And now I'm not going to install GoRouter over here, but you can think of it that way, that if you're using GoRouter, you could not pass instance of the block of the counterCubit, and because of that, it would cause problems. Also, it would just be so annoying just to pass counterCubit every time you navigate to this page. Let's say your app has 100 pages, it would be pretty annoying to pass a counterCubit instance every single time. So this solution that we used using BlocProvider is a neater and a better solution overall. But right now, I'm just going to use Navigator because we're not adding any other package complexity. And I can just use push material page route context, and I can just go to the increment decrement page. And now when I click over here, I go to the new page, I'll increment this, and you see it is 1 now. I'll again go to this page, I'll increment it, and it's 5 now. Since it's the same counterCubit instance that's being updated over here, and the same counter instance that is being displayed over here, we get the same results. And that is the beauty of state management overall. And thanks to BLoC, we don't have to install provider anymore. We can just use BlocProvider to provide our blocks. Of course, if you have other classes to provide, you can just use provider as well. But BlocProvider provides the guarantee that it's always going to return a block or something related to block. Obviously, this is a Cubit, but something related to a block. So that's our end for the counter Cubit. Now we're going to dive into BLoC and see how we would manage state using BLoC instead of Cubit. I'm going to keep the same Cubit code, and I can also keep the same layout, home page and increment decrement page, so that we know that the state is being managed globally. It is being managed app-wide instead of just on one single screen. So let's get into state management with BLoC now. So similar to a Cubit, we'll be creating a folder for BLoC as well. So we can just write in BLoC, and you'll see there are different icons for BLoC and Cubit. It correctly identifies them. And in here, I'm going to create counter block dot, and it serves the same naming convention. Counter is the state that I'll be managing so that I get an idea of what I'm managing. And BLoC tells me that I'm using BLoC inside of this file. And then I can click enter. Then I'll create a class called as counter block, but instead of extending it with Cubit, I'll be extending it with the BLoC class that comes from the Flutter Bloc package as well. And we get the same error that the super class doesn't have a 0 argument constructor. So we need to create a constructor which says super as 0, because at the end of the day, we're just managing the count over here. So it's going to be an integer again. So that was pretty similar to Cubit, right? Where's the difference? If you remember, in Cubit, we passed an integer over here saying that our state has the value of an integer. But in BLoC, just passing integer isn't enough. BLoC requires 2 arguments over here. You see, it requires an event and a state. In Cubit, only the state was required because there was no concept of event in Cubit. BLoC has the concept of event. So what are these events? Events are the input to a block. So if you have like a button press, that is an event that can be captured and sent to this counter block, using which we can update the state. So in Cubit, we had to create a function and we could call that function, but in BLoC, there's no need for that. We can just create our events, and based on those events, we have to create event handlers, and then the state will be updated. So let's see it in action. So how should I create my event? To create an event, you can just create a class. So let's say I want to have an event which says counter incremented. Let's call it incremented. And that would be my event, right? That's how easy it gets. This is one event. The naming convention for an event is like this, because first we need to mention the name of the block, which is counter, followed by the action that the event is performing. And the action it is performing is it's incrementing. So it's counter incremented. And the reason we have to put this counter before is because let's say we have hundreds of blocks created in our project. Later on, we'll get confused if we just name it incremented. If I just say incremented event was called, it can be quite confusing. Where is this incremented event even there? It's in the counter block, right? So I can just call it counter incremented. Now I can just take this event and pass it in over here, right? And that fulfills my block. That's all it ever wanted. An event and the state. Now I can just provide this block just to see the initial value. I can go to the main.dart file, and I don't want to remove this counter Cubit just yet. I'll remove it later on. So I can just have another BlocProvider created over here. So I can just do BlocProvider, create, and I can return my counter block from here. And obviously the child for this is going to be the material app. So let's take this material app and paste it over here. Easy. But you see, the nesting can be pretty deep, and Provider has already taught us that if the nesting goes way too deep, we can just use multi-provider. In BLoC, there's a similar thing called multi-block provider. We can just use that. So here we can just pass in a list of providers, and I can just pass in block providers. So I'll just pass in my counter block. I also need to pass in my counter qubit. So let's copy this. And now I think I can remove my block providers from here. And there we go. So instead of nesting block providers inside of each other, I've just created a multi-block provider which requires a list of providers, and there I have it, no more nesting. And it should work the same way, so let's see if it still works. I'll just increment, I'll go back, and it's on 4. So it's still working. Now that I have counter block provided, I can just go to my home page, and instead of using counter qubit over here, I can just use counter block, right? So here I can just pass in counter block, and I don't even have to pass counter qubit anymore. So I can just do final counter block is equal to BlocProvider dot of counter block context. So this way we get access to the instance of the counter block, which we can just pass it over here, and there we go. If I restart, it would show the 0 for me, but when I try to increment it, it won't show the updated value because we're using counter block and the changes are happening in counter qubit. Another interesting thing that I can show you is we don't have to pass block over here anymore. We can just do this and it would still work. The reason for that is we've already specified counter block over here. Since we've already specified counter block and we've not specified any block value over here, because of which it is optional, what BlocBuilder does behind the scenes is it goes up the widget tree trying to find a block provider that returns counter block. And once it finds it, it will take that instance and that will be the block it will build on. And the same goes for Qubit. I don't have to mention counter qubit over here. I can just do this, and just to prove it to you, I'll restart. I'll come over here, increment it. I'll go back and you see it is 6. So only if you have created providers at the top, you don't have to mention the block. If you have not mentioned the providers at the top and you're just creating an instance, then it needs to be passed in because it doesn't know counter qubit instance was created anywhere. So keep that in mind. Now we'll again change back to counter block, and as a result, we don't even need this. So we can remove it. So now that we can see the initial state, let's go ahead to our counter block and see how can we respond to certain events. So we have a counter incremented event. As I said, whenever we have a certain event that was created, we need to create event handlers for it, and they can't be any functions. So how do we create those event handlers? To create those event handlers, you can just create a body of the constructor, and in the body of the constructor, we can type on. And once we type on, the first thing we have to do is create a generic type over here and ask, what is the event that we want to capture over here? I want to capture the counter incremented event, so I can just do that. So on counter incremented, I have an event that I get and the emit function. Event is the event that was captured, so counter incremented because that's the event that we're capturing, and emit is basically updating the state. In BLoC, we cannot use emit outside of these handlers. So if I just create, let's say, a function, and here if I just say emit, it does give me access to emit, but it gives me a warning saying the member emit can only be used within this package or a test file. We cannot use it over here. So that is the difference between Qubit and BLoC. The emit function will be given out by an event handler to us, so we don't have to worry about that. And now, whenever the counter is incremented, we just have to do emit state +1, and we do get access to state over here. State comes from the BLoC class, so that's all good. And that's all we have to do. We have to create a block, we have to create an event, and based on the event, we have to create an event handler, and based on the event handler, we have to update the state. Now, I can go to the increment decrement page, and instead of using BlocProvider of CounterCubit, I can use BlocProvider of CounterBloc. And you see, it doesn't have increment and decrement functions anymore. So let's update this. It's CounterBloc, and we can do CounterBloc dot, and it will tell us the list of functions that are available on this instance of the class. So many of the functions are same, like close, emit, onChange, onError, but we have to use add. When we use add, you'll see that it requires counter incremented event. So it needs an event which is, well, counter incremented. So I can just add the counter incremented over here and we're good to go. Temporarily, I can just uncomment this because we have not implemented decrement event. So let's restart the app and see if it works. I'll come over here. I'll click on this navigate button. I'll click on increment. I'll just do it a few more times. I'll go back and it's 5. The state management using BLoC is completed. What we have done is on this instance of CounterBloc, we've added an event and the event is counter incremented. As I said, we cannot call functions on BLoC, so we need to use events and add them to the BLoC. As soon as we pass it to the BLoC will run this and see, hey, which event was captured? Counter incremented was captured. Okay, let's run the body of this counter incremented event handler. And then it would update the state, and then we have our usual configuration in the home page of BlocBuilder that rebuilds this thing whenever the state changes. So that's a neat solution. Now let's do the same for counter decremented. I can just do class counter decremented, and now I can do on counter decremented event emit, and there we go. But why is this giving me an error? It is giving me an error because it says counter decremented doesn't conform to the bound counter incremented of the same type parameter e. Try using a type that is or is a subclass of counter incremented. The basic problem over here is you've said the event is going to be counter incremented, and it can only be a counter incremented event then. So what about other events? I have other events in my app. There's not just one event. I also need to pass in counter decrement, and I cannot pass in a list over here. Neither can I pass multiple events. So how should I go about solving this problem? It does give us a hint over here. It says try using a type that is or is a subclass of counter incremented. It is basically saying that, hey, you need to create a parent class which has multiple events attached to it. So what we need to do is create like a super class over here, and this super class will have multiple events attached to it. So there can be counter incremented, then there can be, let's say, another event which would be counter decremented, and there could be a third, let's say, counter restarted. So these are the 3 events that I can create from this particular parent class. So I can just go ahead and create a super class. Now this super class can be any class you want, but I'm going to take advantage of the Dart3 modifiers that were released previously in the year. So I can just do sealed class counter event and extend all of these classes with counter event. But why did I choose this to be a sealed class? The reason I've used a sealed class over here is because, let's say I have a switch with me. Let me put it out, void function. And from this function, I'm getting a type of counter event. I don't exactly know what the event is, but I just know it's one of the counter events. And I can create a switch based on this event. There's no notable difference over here. But if I just extend these classes with counter event, I can just have counter event over here. You see, we start getting errors saying the type counter event is not exhaustively matched by the switch cases since it doesn't match counter incremented. It basically starts telling me that, hey, you've not put one case over here. You've not put the case of counter incremented. It gets to know which classes extend counter event. So if I just put case counter incremented, we're good. But after that, let's say I also extend it with counter event, it gives me another error saying that we have not passed a counter decremented. So that is the benefit sealed classes give us over abstract class. You could use abstract class, but that's the benefit I see with sealed class. That's why I'm going forward with it. If you want to know more about these modifiers, you can check out my Dart 3 video. Alright, so now the change I have to make is instead of using counter incremented over here, I have to put in counter event, and now the error goes away because counter incremented extends from counter event and counter decremented also extends from counter event. And one small improvement I can do is just put a final before both of these classes. And the reason they were made final is that these classes, if they're final, cannot be extended, implemented outside of this library. So that's a good thing for me. Alright, so if we have a counter decremented event, I just want to do emit state -1. And that's all. Now you see, we have our counter block and our counter events in the same file. And it can be pretty confusing if we have more than just 2 events over here. There can be 20 or 30 events. So it would be a good idea just to shift all of these into a separate class of their own. So I can just go to BLoC and create a new file over here called counter event . Then I can paste all of these 3 classes. Then I come over here to counter block and import them in. But instead of importing, there's another thing we can do. We can just use part over here so that they're considered as a single unit. So I can just do part counter event . And in counter event, I can do part of counter block . With this, the error goes away. What this is basically saying is that counter event is a part of counter block . And here we are just specifying that we have a part of counter event. So with this, we don't even have to import it, and we can do multiple things with these counter incremented. For example, I said these counter incremented classes cannot be extended outside of their library. So if we imported it, we wouldn't be able to extend the counter incremented class. But now we can, because they're in the same library and they're considered as a single unit. Another thing you might notice, if I just remove these things, in increment decrement page, we get an error. The error is there because we have not imported counter incremented over here. We have to implement that from the counter event class. But if I just use part and part of, the error goes away because they're all inside of counter block . They're considered as a single unit. So I hope that was clear. That was a lot of explanation, I agree. I can just restart the app. I can go to the new page. I'll increment a little, decrement a little until we get to 0. And the reason for that is in the increment decrement page, we forgot to add the event of counter block over here. So let's add it, counter block.add, and we can add the event of counter decremented. We can save this, restart it, and now I can press this 1, 2, 3, 4 times and this 2 times. Now I can go back and the output is 2. If I want to decrement it further, it can be -2. But we can also add the logic in counter block saying that if state is equal to 0, then we want to return from here. Simple. The same logic that we added in counter Cubit as well. So that is the difference in the code between counter block and counter Cubit. You can compare it on your own and see what differences there are. We're going to dive into more differences as we move forward in the tutorial, but the differences that we've already covered are that BLoC relies on events and qubits rely on function. The functions need to be called and these events need to be added to the counter block. The emit function is also not available outside of these event handlers. In Cubit, the emit function is available for all the functions. One interesting fact about BLoC and Cubit is that if we just go to their source code, we'll see BLoC extends BLoC base, and if we go to the Cubit source code, Cubit also extends BLoC base. That basically means that both of them have the same public API, and that's a good thing. So that's all there was to cover with respect to the counter app. Now let's dive deeper into the Cubit by creating a to-do list. So the next app that we're going to focus on is the to-do list app. You can find the link to the beginner files mentioned in the description below. So let's explore what we already have. In the lib folder, we have 3 files, main.dart, which contains the material app with named routes passed to it. And the home route is the to-do list page, which only has an app bar, a body that we need to implement, and the floating action button, which takes us to the new page. So this is how the screen looks like. And when we click on this floating action button, we can add a new to-do, which takes us to the add to-do page, and it only has an app bar, a text field, and an elevated button. So we can add a to-do from here, and once we add it, we want to display it on the screen over here. Just a very simple to-do app. For this, we are going to use the Cubit state management. We're not going to implement this with BLoC. However, if you want, after the Cubit one is done, I would recommend you to try this on your own and see if you're able to do it with BLoC. So as usual, in the lib folder, we are first going to create a Cubit. And actually, instead of creating a Cubit folder and everything by ourselves, I have a shortcut that I wish to show to you. If you go to the extensions tab in VS Code and search for BLoC, you'll see this package by Felix Angelov, who is also the creator of the BLoC package. You can just install this VS Code extension, which will provide us with the tools to create blocks and save much of our time. And now if I just press Command-Shift-P and type in new Cubit, you see we get this option to create a new Cubit. We can just click over here, and then we need to pass in the Cubit name. The Cubit name is going to be to-do, and we don't have to add to-do underscore Cubit. It will do that automatically. We just have to pass in the Cubit name and click on enter. And then we need to specify the location where we want to create this. So I just need to do this in the lib folder. So I'll just select the lib folder, and there we go. We have a Cubit created with to-do Cubit and to-do state passed to it. Now if you dive into the files, you'll see we have a to-do Cubit, which imports the BLoC package and the meta package. And it also creates to-do state, which basically creates the state. Now we don't need state for our app, so we can just remove this file and then go to to-do Cubit and remove these 2 packages as well, and even this line. Now we need to import the Flutter Bloc package. So first we need to install the Flutter Bloc package. So we can just do Command-Shift-P again and type in add dependency, and then type in the package name, which is Flutter Bloc. So with this, it would add the Flutter Bloc package to our pubspec.yaml file. There we go. And now I can just import the Flutter Bloc package right over here at the top. Nice. Now a little boilerplate code is already created. We want to pass in the to-do state and the initial value of the state. So let's put both of them. Now, what is our state going to be? Essentially, this Cubit is just going to store a list of to-dos in our app. Whatever to-dos we create, we need to store them in the state management tool, which will be used to display it on the screen. So that's our purpose with to-do Cubit. So it should be a list of to-dos, right? Now, I don't really have a to-do created. So we could just do list of map of string, but I always prefer to create models for my to-dos. So I'll just go in the lib folder and create a model for to-dos. It just structures my data really well, and I prefer it that way. So I can just create a to-do model.dart and call it, let's say, just to-do. Now it's going to have 2 fields, final string name and final date time created at. So what is the name of our to-do and when was it created? Now I can just create a constructor for it. And to create constructors and data classes really quickly, there's a nice extension you can use, which is the .data class generator extension over here. You can install this and it will help you create constructors, data classes really quickly. So I'll click on generate constructor. I can remove this line and there we go. Now in our to-do Cubit, my state is a list of to-do, right? Now I also need to import the to-do model. There we go. So my state is list of to-dos and my initial value for the list is going to be empty, right? So I can just pass in an empty list like this and there we go. Now that we have all the initial setup done, and I hope you've understood what we have done over here. So just to recap, we have extended it with Cubit. Then we have a list of to-dos that are going to be our state, because every single time we add a new to-do, we have to store it in a list which will be displayed on the main screen. And the initial value for the state is going to be an empty list. Now we need to provide this Cubit, so I can just go to the main.dart, wrap my material app widget with BlocProvider widget. And if you scroll down, you'll see we have BlocProvider over here. We get this option because we have installed the BLoC VS Code extension. So now I can just wrap it with BlocProvider and the name is to-do Cubit. So I can just use that. There we go. And I also need to import BlocProvider. So I'll import that on the top. Nice. So now that we have done this, we can just go to the to-do list to display the list. So here, to display a list, we have to use a list view builder. We already know that. We get a context index and then we have to display it. But what is our item count going to be? To get the item count, we need to get the length of the state from the Cubit. And for that, we've already seen we'll be using BlocBuilder. So we need to wrap this list view builder with a BlocBuilder. So I can just wrap it with the BlocBuilder widget. And then we need to specify the type of the block and the state. So it's going to be to-do Cubit. And the state is going to be a list of to-do that we're going to get. All right. Also make sure you import the Flutter Bloc package over here as well. And there we go. So we have the body as a list view builder, but then we realize that we need to get the length of the state. So we wrapped it with a BlocBuilder to get the state value. We've already seen this before in the counter app as well, so I'm rushing through it. Now in the item count, I can just do state.length, right? The state that I get here, I'll just use its length. But just to be more descriptive, I can just name it as to-dos and then call it to-dos.length, because the state is essentially giving me a list of to-dos. And now in the item builder, we can get one particular to-do, which will be to-dos at one particular index, and then we can return a list style where the title is a text of to-do.name. And this is why I created a to-do model if you were confused. When I used map string comma dynamic, I wouldn't get this autocomplete thing over here. Now it auto suggests me to use name or created at. If I used a map, I wouldn't get that. I would have to do something like this and it could possibly be misspelled or anything. That's why I created a model so that we have more structure to our app and our code. And again, just to remind to you, this BlocBuilder doesn't have a block over here. It automatically goes up the widget tree trying to find to-do Cubit provider. And once it gets that, it uses that value. Once we have a provider created, we don't have to worry if we specify block over here or not. But if you don't, or you want to, let's say, override the value, then you can use the block over here and it would work just fine for you. So now on our screen, we are not able to see anything because initially the list is empty. Now we want to update that empty list to fill in some to-dos, right? So as soon as the user clicks on this add button in the to-do, we want to add it to the list. So we can go to to-do Cubit and here we can add a function called add to-do. It's going to get a string title and then based on this title, I can create a to-do, right? So I can just do final to-do is equal to to-do. The name is going to be the title, and created at is going to be datetime.now because it was created literally just right now. And then I can emit that to-do. Is that fine? Not really, because if we emit a to-do, we're just emitting one to-do. We want a list of to-dos to be emitted. And if I just wrap it with the list, it would throw away all the errors, but every single time we create a new to-do, the previous one will be overridden. So if I create a to-do, let's call it hi, and click on add, it would be added over here. But when I again try to add another to-do, let's say hello, the hi to-do would be replaced by this hello to-do because our new state is just one to-do. Our new state should be the previously existing to-dos along with the new to-do that we created. So to do that, can we just do this state.add to-do, and then I can just emit the state. That should work fine, right? Let's see if it works. What I'm going to do is go to the add to-do page, and as soon as the user clicks on the add button, I just have to call this function, the add to-do function. So I can just use BlocProvider .of context, and then I need to provide the name of the provider. So it's to-do Cubit dot add to-do, and the title is the to-do title controller .text.trim. To-do title controller is the controller that was attached to this text field. And in case you're just irritated by how long this BlocProvider of context is, there's a shorter way you can use this, and that is context.read to-do Cubit and then call .add to-do on it. So this is a very similar thing to provider. It's present in both the things. You can use BlocProvider.of context, or you can just use context.read. It would work fine both the places. All right. So now I'm just going to restart my app and click on add to do. I'll add hi, click on add, then I'll go back. Hi is showing up. That's nice. Now I'll add another to do. Let's call it hello. I'll add it. I'll go back, but I don't see hello over here. Maybe it was a glitch. I can just try it again, right? I can just type hello again, and then if I click on add, go back, nothing happens. The state is as it is. Let's try to see where the problem was. I'm just going to go ahead and print the state and see what it always gives me. I'm going to restart my app as well. Now I'll click on add to do, hello. I'll click on add, I'll go back, hello shows up, and it says instance of to do over here. That's good. Now I can again type in hi there. I can click on add, go back. It still doesn't show up, but the state is updated and it is instance of to do, instance of to do. It shows instance of to do 2 times. That means a list is being updated and everything seems to be working fine over here. So why are we not getting the real output on the screen? And to understand the reason, we must hover over this emit function and read this section. It says emit does nothing if the state being emitted is equal to the current state. So emit doesn't notify any of the listeners if the state being emitted is equal to the current state. If this state is equal to the current state of the qubit, and current state of the qubit is known when emit just asks this to do qubit that, hey, what is the state over here? And once we call state.add, we're basically saying our current state is this to do. So the current state and the state that we are emitting is the same thing, which is why it doesn't notify its listeners. Just to demonstrate to you in terms of a diagram, let's say this is our current state. And let's say our current state is having one to do already. The name of this to do is, let's say 1, just so that we have less complexity. Now we get a request to add a new to do. Once we get a request to add a new to do, what we do is take the title, then we create a to do out of it, add it to the state. This is the current state. So I just take the to do and add it over here. So now my current state is having 2 to-dos, and then I'm emitting this current state. If I'm emitting this current state, the current state and the state that I'm emitting are the same thing. So it thinks nothing has changed, and because of it, it doesn't notify the listeners that the state has changed. And the same thing happens when a third to-do is being added. A third to-do is added to the current state. So this part is done, and then we are emitting the state. We are emitting the same current state, so it's thinking current state is equal to the state that is being emitted. So it's the same thing. We don't have to notify the listeners about it. This is why we don't get any updates. So how do I make sure this works? What I can do is, instead of using state.add, so what I can do is, once I've added the state, I can just create a new list based on this. So I'll just do this, and then I'll put 3 dots, which is a spread operator. So doing this, we get each of the elements in a new list that we created. So this is different from the current state that we have. So the state that we are emitting, it looks very similar to the current state, but it's not equal. They're not equal to each other. They have a different identity. This is a separate list of its own, and this is a separate list of its own, and that's what we've done. The elements are the same, but the identity of the object is different. And that's why this should work. Let's go ahead and try it. We're going to restart the app. I'll click on add to do. I can just say, hey, click on add. I'll go back. Hey is showing up. Let's try to do the same thing. Hi, click on add, go back, and the hi also shows up. Now I can add a third value, go back, and it shows up. So now this works. Alternatively, what we could have done over here is, instead of just doing this, we could have created a new list over here and then added to do. This would have the same result. What we are doing is saying that we want to emit a new list which encompasses everything of the previous list plus a new to do. And now we'll be able to see the new output. So I can just click on hi, that shows up. I'll do it again, hello, and it shows up. Nice. So now that we're able to do it, I just want to make one small change, and that is, whenever a new to-do is added, I can just do navigator.offContext.pop. So it would just pop the screen so that we go back to our default or the home screen. So I'll just say hello, there we go, and it's able to add new to-dos as well. So our state management using Cubit is done, but there's more to Cubit than just having functions that would change the state and super. There's more you can do which will help in developer experience. You see, every time we have to debug if the value changed or not, we have to put a print statement over here. And that's not a cool thing. What if I don't want to put print statements every single time? I want to get a log of every single time a value in a Cubit changes. To do that, I can just use something known as onChange, which is provided by the Cubit. Using onChange, I can just print the change and see what it has for me. So I can just do this. Now I'll restart my app. I'll press Command J and come to the home screen. Let's add new to-dos. So I'll just say hello, click on add. And now if I come over here, you see, it says there's a change, and the change is that current state has been changed from an empty list to an instance of to-do. That's really helpful for me because I get to know that, hey, the change has occurred. The current state has changed, and it would be really helpful for me if I have like 100 qubits and I get to know that certain qubit has changed. Now to make this more specific, you can just add the qubit name over here as well. So it's the to-do qubit that has caused the change. So I can just do this. And now if I just add a to-do again, I'll click on add. And here we have to-do qubit has a change. That current state has changed from an empty list to an instance of to-do. Now, just in case this instance of to-do is bothering you and you really want to see the elements inside of the to-do, you can just go to to-do model and here click on this bulb icon and click on generate toString. This would create a toString method for you, because of which now every single time you create a new to-do, let's call it hi, it would say that the change is current state, which is an empty list, to next state, which is this to-do. It shows the elements of the to-do so that it's helpful for us. It no longer shows just instance of to-do. So that's one cool thing you can do with Cubit. Another cool thing is the onError method that you can use, provided by Cubit again. Every single time you have an error, you can just print the error over here and see what the error was. Now to see this in action, what we can do is just put a check over here that if title.is empty, then we want to throw an error that, hey, you cannot just put a title that is empty. So I can just put add error, and then I can say title cannot be empty. All right, and I can just return so that no further execution in the function happens. Now I can restart the app, and now if I try to add something, it doesn't add it to the list. That's good. And it prints the error for us, which is title cannot be empty. Now again, just to make this more specific, you can use string interpolation over here and do to do Cubit as error. Now again, if you try it, you'll just see to do Cubit title cannot be empty, and it doesn't add it to the list. So that's another cool thing you can do. So that's pretty much everything you might want to use in Cubit. So with these simple little things, you can modify your code to be much better in terms of programmer experience. So that's everything I wanted to cover with respect to Cubit. The main advantage of Cubit is that it's really easy to use, especially when compared to BLoC. You can just create your own functions and call those functions. In BLoC, you need to create events, you need to create event handlers, all of that stuff. So that's one advantage Cubit has over BLoC, and one of the reasons you might want to use Cubit over BLoC. But now let's dive into BLoC. So the next app that we're going to work on is the login form validation app. To get these beginner files, I've linked it in the description below. You can check it out and install it in your system. So just to walk through this is what we have. There's only one screen in this app, which is the login screen, and this is how it looks. There's a text at the top, there are two buttons, which are the social buttons, and there's a separate widget created for it over here. Then there are two login fields, which is like the email and the password field. And after that, we have a gradient button, which is again in the widgets folder. So that's all there is to this app. Now what we want to do in this is use BLoC to add validation to this app. So basically, whenever I enter email, password and click on sign in, it should give me the appropriate errors. If there are any errors, for example, if the user did not enter a valid email or did not enter a valid password, then just show a snack bar or something. And if the user is successful, then we'll go to a new screen which shows the user's email, their password and all of that stuff. So the first thing, I'm just going to install the Flutter Bloc package. After we've installed the Flutter Bloc package, the next thing we want to do is create a separate block file for this authentication. So I'm just going to click on lib, right click, and you see we have an option to create a new block. Alternatively, again, we can just do Command-Shift-P and just say new block, and we would get that option. But this is just another way of doing the same thing. So now it asks us for the block name. My block's name is going to be auth. And I can just click on enter, and you see it creates a new block package over here. It has auth block, auth event and auth state in it. We already know what auth block and auth events are. We ourselves separated them in two different files in the counter application. Let's go into each of the file and see what it has to offer for us. So there's auth block. Now it has two files here, block and meta. We don't need any of them. We only need the Flutter Bloc package, which we can import. There we go. Then we have our auth block extending block. The event is auth event and the state is auth state. In our counter app, the state was an integer, but in this case, it is going to be auth state, and we're going to understand why. Then we have a constructor with auth initial as the super argument, and then we have our event handlers created. So our first event handler is on auth event itself. So any event that's added over here will be handled in this particular event handler. Now let's go into auth event. In auth event, we just have a sealed class, which is the auth event, and it's immutable. So if you want to keep it immutable, you can just press command full stop and import foundation.dart, but I'm fine with not keeping it immutable also. So there we go. Now, in case you don't want to import any Flutter related files over here, you have to install Meta, which was present over here by default, but I don't mind that. I can just have foundation.dart over here. So the foundation.dart here is present only because this immutable is present in one of the files that is part of auth_bloc.dart. And we've already understood what part and part of means in the counter application, so I'm not going to dive into it. Then we have a third file, which is the auth state. It also has a sealed class, which is immutable, and a final class, which is auth initial. Now let's get our objective straight with this auth block. What is it supposed to do? What I want to do is, as soon as the user clicks on sign in, I want to handle that event, right? So I'll need events like login button pressed, or the user is trying to log in, that event. And what should the response to this be? The response to this would be, well, just that if it's a success or a failure. So was this sign in button clicked on? Was this a successful event, or there was an error? The error could be that the email was not entered, password was not entered, password was 6 characters or less, and email was not a valid email. So those are failure things. And the success is just that the sign in is successful. We can just go to the home screen and see the user with the new email. So now that we have clear goals about what we want to do, we can just go to auth event and here create a new class, which is login requested, right? So we can just do final class auth login requested. Now, instead of naming this auth login requested, we could also name it auth login button pressed, and that would be fine as well. I'm just going to call it auth login requested, and this should extend the auth event. So we have our event created now. The next thing I want to do is, well, create an event handler, right? But before that, I want to manage the state as well. So what is the state going to be? As discussed before, it's not going to be integer like before or a string like before. We have a special state that we want to emit. We want to emit if it's a success or it's a failure, and that is not provided by Flutter by default. So we need to create our own class saying that this is auth success state and this is the auth failure state. So we can go to authState.dart. Now, obviously you could create your auth states over here as well, and that would be fine. But as mentioned before in the counter app, that we don't want to pile up everything in just one file. This file is just related to auth block, and auth event will be related to everything about events, and auth state will be everything related to state. So here you see it has a sealed class of auth state. There's auth initial. Now I want to keep this class because that's what my initial state is going to be. I'm not going to say that my auth state initially is going to be a success or it's going to be a failure, because I don't know if it's a success or a failure. It's none of those in the beginning of the app. When the app starts, it's none of them. It's just auth initial. That's the state. It's just in the initial mode. After some input occurs or something occurs, the auth state can be auth success or auth failure. So I'm just going to keep this class as it is and thank BLoC for creating it. Now I can just do final class auth success, which would extend auth state, and I can create another class which is auth failure and extend that to auth state. Awesome. So we have our 3 states with us: initial, success, and failure. Now let's catch the auth login event. So I can just do on auth login requested. I catch that, and now I will implement this event handler. So as soon as I get the auth login request, what do I want to do? And in a real life scenario, what I want to do is get the email, get the password, and check their validity. So if the email is valid or not, or if the password is less than 6 characters long or not. But right now, I don't have access to either of them. How do I get access to it? Well, for that, I would have to capture those events and those inputs from the user. So let's go to the login screen and try to pass it in. So in the gradient button, we have to create an onTap function. So onPressed over here is empty. What I want to do is just take this onPressed from the constructor. So I have void callback, and I'm going to call this onPressed, and I'll require this onPressed from the constructor. I'll also take this onPressed and pass it over here. Now I can just go to the login screen, and in gradient button, it is going to be onPressed like this. So as soon as the user clicks on this button, I want to take the email, I want to take the password and pass it to the user. To do that, first I would have to get access to the block, and auth block is created, but I've not mentioned it in main.dart file with the BlocProvider. So let's do that really quickly. So I'll just wrap it with a BlocBuilder. We're already used to all of this now, I hope. So we can create auth block. I'll import Flutter Bloc package. I'll import the auth block.dart file, and there we go. I know I've rushed this a little bit, but we're just creating a BlocProvider and returning the auth block from here. Now I can just go to the login screen, and in the onPressed, whenever the user clicks on the sign in button, I'll call the auth login requested event so that my auth block can handle it. So I can just do context.read, and we've already seen this with Cubit. This is also accessible in BLoC. We can just do auth block and then call dot add, and we'll add the event of auth login requested. But now you see the problem? The problem is I cannot pass the email and the password from here. Add doesn't have any other constructor to take. It just has an auth event that it can take. It cannot take any arguments that are provided. So how do I pass it in? Well, the solution is just to go to auth login requested event in auth event.dart, and here we will accept email and the password. So I can just do final string email, final string password, and then take that from the constructor. So I'll just create a constructor for this field, and there we go. Now I'll also put comma so that the formatting is correct. Now what I'm saying is that every time we use this auth login requested event, I have to pass the email and the password from the constructor. And because of this, in the login screen now, since I've called auth login requested class, I can pass in the email, which is email controller.text.trim, and password as password controller.text.trim. That's pretty much everything we have to do in the UI part. Now I can go to the auth block and access that. So I've already mentioned that this is an auth login requested handler. So I can get access to the email and the password from this event. This is also of the type auth login requested, right? So I can just get the email saying final email is equal to event.email. Since this is of the type auth login requested, I can get access to the email and the password property. And similarly, I can also get the password, which will be event.password. Simple. Now I can perform any validation or sanitization I want. I can just check if password dot length is less than 6. If it is less than 6, then I want to emit a state saying that there's a failure. So I can just say emit auth failure. But along with the auth failure, I also need to pass in some message telling that what exactly is the auth failure. What went wrong? We need to tell the user, right? Otherwise, we'll just tell them that there's an error, but they don't know about the error. We want to give them input about the error. So in the auth state as well, we can go to auth failure and here ask for the error message. or just error. And we can create a constructor for that as well. I don't want it to be a named argument. I can just pass it as a positional one so that I can directly mention over here, password cannot be less than 6 characters. Simple, right? And we can perform a similar validation for email as well. Now you can use regex for it, and that would be a good choice, but I'm not diving into all of that. I'm just putting in a comment saying email validation using regex. All right. So you can do this on your own. I've already done the validation for password length. And we also need to return this because we don't want further execution to happen. It will emit this, and after that, it would continue forward. Emit is not like return. So we need to specify a return over here. Or if you don't want to do it in 2 lines, you can just do it in 1 line, doing return like this, because emit does not return anything. Now that we have this out of the way, you know all of the validation and sanitization can be performed here. Now, let's say everything was successful, all right? Now how do I emit this? So I can just do await future.delayed. And you see, we need an await call over here. So I would want to put async for this function, which I can put. On function can be asynchronous as well, and that's a good thing. So I can just put await here and say future.delayed duration seconds 1. And it would be a constant. Now why am I doing future.delayed? Just think of this as a mock service call that I'm doing. So just imagine that you're trying to talk to your database to fetch the details of your user once the login is successful and all the validation is correct. So you're trying to get their data. This is what I'm trying to mock over here, that the data is coming from an external API that you've created. Or to put it more simply, the data is coming from your database. So that's what I'm just mocking over here. So after a delay of 1 second, what I want to do is run a function here saying there's a success. So we can just do return emit auth success, right? But again, with success, I want to pass in some user data. So I can just go to the auth success class, and here I can just create final string UID and accept that through the constructor. So I can just create a constructor, and there we go. Now, instead of having just a UID, it could be, let's say, a user model as well. So if you have a complex application, you might have a user model where you want to store the user data. For us, it's a UID. So let's pass in the UID, and my UID is going to be based on the email and the password. So I can just do $email, $password, and that's my UID. In a real world application, this UID is going to be the one that comes from your database. And of course, since there's an async await over here, and we're just assuming that we're talking to a database and a repository, we have to put a try and a catch block just in case any exception occurs. So I'll catch that exception and I'll just return that. So I'll just return emit auth failure e.toString. Easy and simple enough. Now let's go to our login screen, and we've already added the auth login requested event. So let's run it and see what happens. So we can add an email over here, which is, let's say, rrr@gmail.com, and test123. I'll click on sign in, and nothing really happens. Why? Because we don't have anything to display on the screen. We're not using BlocBuilder anywhere or anything like that. But do we even want to use BlocBuilder? There's no state we want to listen to and display something else. There's no state change that we want to display. All we need to do is whenever the user clicks over here, we want to tell the user if it was a success or not. If it was a failure, then I want to display a snack bar. And for that, I cannot use a BlocBuilder. BlocBuilder is there just so that whenever the state changes, our UI is rerun. That's all BlocBuilder does. So I cannot use BlocBuilder, that's clear. What else should I use? Well, there's BlocListener that we can use. So we can wrap our entire single child scroll view with a widget called as BlocListener. And over here, we need to mention the block. So it will be auth block and auth state as it is. That's really nice. And it gives us a listener argument. Now, what does BlocListener do? Well, based on the auth block event that it has, it will listen to the state, and if there's anything we want to do about it, let's say we want to navigate to another page, we want to display a snack bar, that's where BlocListener will help us. So whenever the state changes, this listener will be called again, which is quite similar to BlocBuilder, but in BlocBuilder, the UI was rerun and rebuilt, but over here, we can catch the particular state, and based on the state, we can display a snack bar. For example, if the password is less than 6 characters, I want to display a snack bar. So I can just say if state, which we get from here, is auth failure, right? This state can be of the type auth state, and auth failure extends that auth state. So if state is auth failure event, that means something has gone wrong. So I want to display a snack bar, and that's where I can just do scaffold messenger dot of context dot show snack bar, and then I can create my snack bar with a content of text. But what is my text going to be? Well, the text is going to be state dot, and you see it automatically suggests error to me. Now you might say that, hey, state is of the type auth state, right? And if we go to auth state doesn't have any argument that has error in it. Only auth failure has the error argument in it. How is it auto recommending state.error to us? And it is able to recommend that to us because we've put a check over here that if state is auth failure, so Dart knows that we are in this particular if condition where the state is auth failure, so it auto recommends error to us. So we can just take advantage of that, and that's pretty cool, right? Now I can just restart the app, and let's say I put in rrr@gmail.com again, but my password is test. Now I click on sign in, and you see password cannot be less than 6 characters. So what happens behind the scenes is that when gradient button is clicked, this event is run, auth login requested, and then this event is caught in the auth block. Once it is caught in auth block, it runs this entire function, and then it checks every single thing. If password.length is less than 6, it returns an auth failure to us. As soon as there's a state change over here, our BlocListener reruns, and because of that, scaffold messenger is also run. So that's what's happening. Now, let's say there was a success. What do we want to do in terms of success? If there's a success, then I want to move to the next page. So what I can do is close all the other files. I'll just keep login screen, and along with that, in the lib folder, I'll create another screen, which is the home_screen.dart file. Here I can import package flutter material.dart, and along with that, I can create a stateless widget, call it home screen, with a scaffold, and temporarily, let's say we don't have any body. We'll get to the body part in just a minute. So we have our home screen, and that's where we want to navigate. Now I can go to the login screen, and here I can put another statement that if state is auth success, then what do I want to do? Then I want to do navigator.push and remove until, where I'll pass the new route, which is material page route, and then I'll pass in the builder, which is the context, and then I'll go to the home screen. That's pretty much all I want to do. So if it's a success, I just move to the home screen and the user gets to know that they've logged in successfully. So yeah, now let's rerun the app and see if it works. So I'll just put rrr@gmail.com. I'll put more than 4 characters now, 6 characters now, and I'll click on sign in. And you see, we moved to the new page. But just for a second there, I thought that this didn't work. And I didn't know that it worked because there was a 1 second delay that I had put. In real life applications, the delay can be much longer, right? So I want to display a loading indicator while everything's loading. How do I make sure that happens? To make sure that happens, I can go to auth state, and now over here, I can add another event, which is called final class auth loading, which extends the auth state. when I do this, I've created a new state auth loading, and based on this new state, I'll be able to display a new thing, which is the loading indicator. Note that this was not put in auth event because auth events are basically inputs to our block. So auth login requested is an input that we can give. Auth loading is a state. It is in the loading state. If you're familiar with async data, how many types of state there are in async data? There's 3 types of state: loading, success, or failure. Failure is the error over there. So that's why auth loading is put in state, not in auth event. Now I can just go to auth block and put in the loading state. So as soon as the try block is starting, I can just put emit over here saying auth loading has begun. I'm not putting return emit over here, otherwise all of this code wouldn't even run. I'm just putting emit auth loading, which means that the state has changed. Now it will load, and now it goes into all of these conditions. And if there's a failure, it would change the state from loading to failure. If there's a success, it would change the state from loading to success. So that's a pretty neat solution. Now I can close this. I can go to the login screen and here handle that loading event. So if state is auth loading, then what do I want to do? I want to display a loading indicator. So to do that, I need to return a circular progress indicator, right? Now, here's the problem. Circular progress indicator cannot be returned from here. This BlocListener doesn't do the job of rendering the UI. It only does tasks like showing a snack bar, navigating from one page to another, showing a dialog, stuff like that, not any UI stuff. So I cannot do it over here. And we know that BlocBuilder is the one that renders the UI on the screen. So we can keep this BlocListener over here, but after that we can also use the BlocBuilder. So I can just wrap the single child scroll view again with the BlocBuilder widget. And now again I'll have to do the same thing, auth block auth state. And here I can just check if state, which we again get access to over here, is auth loading. If it is auth loading, then I want to return a circular progress indicator. And I also want to center it, so I can just wrap it with a centered widget. Nice. Now I can just restart the entire app and see if it works. So I'll just do rrr@gmail.com, test 1, 2, 3. I'll click on sign in. You see, we get the loading indicator and then we move to the next page. Brilliant. But don't you think there's a problem with this code? In bigger apps, literally almost all the screens will have conditions like this, where we'll need listener and we'll need builder as well. So we can't keep on nesting stuff again and again because this is so much code to write. Instead of using BlocBuilder and BlocListener nested together, what we can do is use something called as BlocConsumer, which is basically the combination of BlocBuilder and BlocListener. That would reduce the code by a lot and would perform the same actions BlocListener plus BlocBuilder would do. So instead of using BlocListener and BlocBuilder, what I'm going to do is again just copy this code so that I don't have to rewrite. Then I'll just remove the BlocBuilder code from here. Yep, so BlocBuilder is removed now. Now instead of using BlocListener, I will use BlocConsumer. And we have our listener, which I'll keep at the top. Then after that, we'll also have a builder. And in the builder, we can have context, state. That's it. And then I can paste my stuff. If state is auth loading, then I want to display a loading indicator. Otherwise, I want to display a single child scroll view. So let's remove the child and return a single child scroll view. So this is our entire code now. We can just use BlocConsumer now. It would have a listener and it would have a builder and it would build stuff accordingly. We don't need a child widget anymore. Now I can restart the entire app. I'll have rrr@gmail.com, test 1, 2, 3. I'll click on sign in. It goes to the new page. It works just as before. The only difference is less boilerplate code now. So just to recap, BlocConsumer is basically BlocListener plus BlocBuilder. BlocListener is used whenever we want to move from one page to another in response to a state, or if we want to display a snack bar. If we want to display a loading indicator instead, we would be using BlocBuilder, because BlocBuilder has the capability to return the UI. So I hope that's clear. Now, the last thing for this is I want to display stuff over here. So I want to display the UID of the user. In bigger apps, you might have the user model. So you might want to display the name of the user and stuff. So I'll just display the UID. Followed by that, I will also create a logout event and just log the user out. So I can just go to the home screen. And now how do I display the UID of the user? To display that, I can just get access to auth state, right? If it's a success, it would give me the user ID. So I can just use the auth state. And as we know, we can use BlocBuilder so that we can display the UI. But there's one other thing you can use instead of using just BlocBuilder, and that is using context.watch. Now you might know this from provider, but context.watch basically always keeps listening to any changes in the state in a particular provider. So I can just pass auth block over here, and this way I'll get access to the state, and that would be the auth state. Now I'll treat this auth state as auth success, because the only way to reach the screen is if the auth is success. So I can just do body as center child text of auth state.uid, and that would be enough for me to display the user ID of the user. So I can just do rrr@gmail.com. The password could be test123. I'll sign in, and there we go. We see rrr@gmail.com followed by test123, which is our user ID. And instead of using BlocProvider, you could also use this. But the only problem by using context.watch is that this app bar will be rebuilt as soon as the state in auth block changes. So if there's any state change in auth block, this entire scaffold will be rerun, as a result of which unnecessary components will also be rerun. So if you want to avoid rerunning or rebuilding extra components, you might want to use BlocBuilder. But I'm fine with that right now. I can just use context.watch just to demonstrate that you can also use this along with BlocBuilder. Now the final thing that I want to do is just add a logout event. So before that, I'll just create the UI. I'll do a very simple thing. I can wrap my center text with a column, and followed by that, I can just use a gradient button. And I understand that the gradient button will say login, but I'm not going to edit that out. This is not a UI tutorial. Just consider this button as a sign out button. All right, now let's go to auth event and create a new event, which is auth logout requested. And we can extend that to auth event. Now we don't require anything from the constructor in this case, because when a logout is pressed, we don't have to do anything. We don't want to get the user email. We don't want to get the user password, nothing. So our event is now created. I can just go to auth block, and here just create another event handler, which is on auth logout requested. So once that is done, I will get access to event. I'll get access to emit. And based on that, I will log the user out. So I can again just do try catch E, and I will emit auth failure just in case some unexpected error occurred. And over here, first thing I'm going to do is again emit auth loading, so that we tell the user that the loading is happening. And after that, I want to just do this, right? I just want to use async over here, and then I'll await future.delete duration of 1 second, and we'll emit, well, auth success. No, auth success is when the login is successful. So I cannot pass that in because I don't even have the UID of the user anymore. what I do need to do is again send back to the auth initial state. Auth initial was the state that was present initially. So we'll again come back to auth initially. There's no error, there's no success. So we just come back to the home screen. As simple as that. Now I can just go to the home screen, and in the on pressed, I can do context.read. Note that I've used context.read over here instead of context.watch. Context.watch continuously watches the state change. Context.read is a one-time event. And after that, I can just do auth block. Then I can add an event, and that would be auth logout requested event. Simple enough. But once this happens, we're not automatically going back to the home screen, right? So we need to make that happen as well. And we'll be using BlocConsumer for that. We want to display the loading indicator. We want to navigate from the home screen to the login screen again. So I can just wrap this with a BlocConsumer, pass auth block over here. And in the listener, I can do one single thing. If state is auth initial, that means I need to go back to my login screen. So I can just do navigator.push and remove until, and then I can go to material page route. Builder would be the context, and we would just return a login screen. So after this is done, we'll finally want to display a loading indicator. So it can be if state is auth loading, then I just want to return a centered circular progress indicator. So this is the same thing that we've done before, and just restart the app. You can just do rrr@gmail.com. Password will be test123. I'll click on sign in. I'm signed in. Now this is a sign out button. So we can click on sign out and we get an error over here. The reason we get this error is because it expected a value of type auth success, but got one of type auth initial. The reason is pretty simple. Here we've done as auth success, and then later on our state becomes auth initial. So it's treating this as auth success, but it's not actually auth success. It becomes auth initial. So we cannot put this line over here. Instead, we have to put that line over here, right? Now this should work. And actually, since we've already used BlocConsumer, which is a mix of BlocBuilder and BlocListener, I can remove this line and instead just use the state to use state.uid, and I can just do state as auth success.uid. Now I can try to restart my app and see if it works. I'll just do this, followed by test123, click on sign in. Here I come, I'll click over here and I go back to the normal page. So earlier we got this error because we were treating state as auth success, but we had clicked on the sign out button, which changed the state to auth initial. So it was no longer auth success, it was auth initial, and we were treating it incorrectly, because of which we got the runtime error. So with this, we have completed the entire form validation and logic of our code. So this app is completed, but there's more to BLoC that we can explore. So the first thing that I want to explore is if we just go to auth_bloc.dart, I just want to let you know that this function can be removed out so that you can write cleaner code. Right now, everything is just put in the body of the constructor. We don't want that. We can make this code cleaner by taking all of this outside and putting them in a separate function of its own. And that can be done over here. I can just say this is void on auth login requested, and notice that I've created this as a private method so that this function cannot be called outside of this block. And after this, I can just paste everything else. Awesome. Now I can just take this onAuth login requested and put it over here. This makes our code much neater. I can do the same thing for logout requested as well. So I can just create void on auth logout requested and paste the same thing over here. And then I can just take this and put it over here. So this makes our constructor, the body of our constructor, very clean. And with this, we also know what all function handlers have we created. And if you want to go to a specific one, we can just go to that. and see it. Another thing is we are getting a warning over here, mainly because we have passed event and emit over here, but we have not specified the type. To do that, we can just type in over here auth login requested, because that's the event that we're catching over here. And the emit can be emitter, and the type of the emitter is going to be auth state. All right, there we go. And we can do the same thing for onAuth logout requested as well. So just paste it over here, and there we go. But yeah, instead of using auth login requested, we have to do auth logout requested. And yeah, so the warnings go away and our code looks much cleaner now. So that's one improvement we could make. The other improvement is not exactly an improvement, but it is the features that BLoC offers. In Cubit, we saw that Cubit used to offer a lot of functions that we could use. For example, onChange. onChange was used just to track the changes that were made. So I can do the same thing over here by printing and saying this is the auth block and the change that occurred is $change. All right. And we also know that onError exists, so we can just use onError as well. But we don't have any error, and you know how to create error, so I'm not going to dive into it. So we can just remove this temporarily. Now I can just restart my app. I'll open my terminal. I'll first pass in an incorrect password. That's just 4 characters. And then I'll click on sign in. It says password cannot be less than 6 characters. And the change here is first, there's instance of auth initial, which goes to loading, as a result of which we see the loading indicator. But instantly after that, we see that auth loading changes to auth failure because the password was less than 6 characters long. If we type in the correct password, and I'm just going to remove everything from the terminal again, I'll click on sign in. You see, we get auth failure to auth loading, and from auth loading to auth success, and that's how it goes. So that was onChange. Another method that's present on BLoC, but that was not present on Cubit, was onTransition. This method is not present in Cubit. You can try it in the to-do list code. It's only present on BLoC, and I'll explain why it is just present on BLoC. But first, let's just print what we're getting over here, the transition. So we can just print the transition over here and see what we're getting. So I'm just going to format it in a similar manner. So we have auth block, and we'll print the transition. But along with that, I'm also going to say this was transition, and this was coming from the change method. All right. Now let's see what the difference between the both is. So I can just do rr@gmail.com again, and there we go. But now you see we have transition happening over here, which occurred before the change. So transition was called before onChange was called. So the current state is instance of auth initial, and that's to be expected. That's the initial state. And after that, the state becomes auth loading. That's very similar to what we see in change, right? Change gives us auth initial and auth loading. But the thing onChange doesn't give us is this event. This event is telling us because of what event did this transition of state occur. What was the reason behind this state changing? That's what we get to know because of onTransition. Since auth login requested was called, auth initial was converted to auth loading. Similarly, auth loading was converted to auth success because of auth login requested. Those are all happening because of the same reason, because auth login requested was clicked on. And in change, we cannot see that. And the reason onTransition is only present in BLoC but not in Cubit is because Cubit doesn't work on events. It only works based on what function was called. BLoC works on the basic concept of events. That's why we get to know what is the reason because of which the transition occurred. So I hope that was clear. And this event part that onTransition gives us is very useful sometimes, because there could be many reasons why the application state could change from the user being authenticated to unauthenticated. So if the user clicks on a logout button, they could go from authenticated to unauthenticated. But another reason could be that the user's access token was revoked and they were forcefully logged out. So with BLoC, we are easily able to see because of what event did this change occur, and that extra information can help in some cases. And in those cases, it's necessary to use BLoC instead of using Cubit. Another area where BLoC can shine is when we want to add advanced event transformations. So when we want to take advantage of reactive operators like buffer, debounce time, throttle, etc., that's where we can use BLoC, and that's where we cannot use Cubit. So for those who don't know, let's say debounce. What is debounce? Debounce is a way of delaying the execution of a function until a certain amount of time has passed. So for example, if we have a login form, we don't want to allow the users to click on the sign in button like 100 times within 1 second. We want to stop that, because if the user clicks on a sign in button 100 times in 1 second, that's not really a user, that is a bot. And we want to not allow that. This might seem insignificant in our app, but let's say we were building a search engine. In a search engine, if there are 100 inputs given, in just 1 second, that's a bot, and we want to disallow the bot to do that. Otherwise, that would be a lot of resources and a lot of database reads calls that were made. So that's where BLoC can help us as well. To know more about these event transformations and what you can do, you can check out another package called BLoC Concurrency, which we can use to create such reactive events. So just to give you a clearer understanding and a clearer summary, BLoC is usually used when you want to take advantage of event transformations, then you want to take advantage of onTransition, so you want to know what event caused a particular state change. But if you don't want to do any of this, then you can just use Cubit, because Cubit is very easy to use. You don't have to create events, you don't have to put much effort into any of this boilerplate code. You can just create your function and get started. Now the last thing I want to cover is not about BLoC or Cubit. It's about another thing that BLoC package gives us access to, which is BlocObserver. Now in BLoC we can override the onTransition and onChange functions, and that would work fine. But what if we don't have just one block? We have like 100 and 200 blocks created. Do I have to write onChange and onTransition for every single one of them? That would be pretty cumbersome to write, and I don't want to do that. Let's say a case arises where we want to change the onChange part. We have a pretty standard way of printing everything, but let's say we decide to change the format in which they're being printed so that we can understand it more nicely. Do I have to go in those 200 blocks and change them every single way? Instead of doing that, can I have just one centralized control? That's where BlocObserver comes in play. So what I'm going to do is just minimize this. In the lib folder, I'm going to create a new file called app.blocobserver.dart. And here I'm just going to create a class app.blocObserver that does nothing but extends a BlocObserver, which comes from the Flutter Bloc package. And here we don't have to override anything or do anything necessarily. However, we do wish to override certain methods, which is first onCreate, which we can do. So whenever a block or a qubit is created, we can get to know they were created. So we can just print them over here. So I can just do block so that I get to know what was created. So after we've done this, we need to register this app BlocObserver somewhere. Right now it's just a class that was created, but it's not called anywhere or registered anywhere. So let's go to the main.dart file, and at the top we can just do block.observer is equal to app BlocObserver. Once we do this and put an equal to sign, I can just restart my app, and there we go. We see instance of auth block created because we've printed a block over here. That tells us that a block was created. Now to give more specialized messages, we can do that. We can just say block.runtime type. That tells us what is the type of the block that was created. And we can also say that this was created. And obviously, if you want, you can just print more information like block.state, which tells us the initial state as well. But right now I'm just going to do this much and let's see what we get. I'll just restart my app and you see auth block created. No other block will be created, so we don't have to do anything else. Now let's look at other methods that are offered. We can use onChange, and we know what onChange does. We can just print the block. So what block was there and what was the change that occurred. In Cubit, there was only change that was given to us, but this is an improvement in BlocObserver because we also need to know what block was changed, right? So we can just do block, which tells us which block was done, and we can say changed $change. Simple. Now I can just restart, auth block was created. Now I can just do this and click on sign in. And here we see transition being displayed. That transition is being displayed because of auth block that we've created over here. So we can just comment them and let's retry again. I'll quickly log in. And there we go. We see instance of auth block changed. It changed from this to this, then this to this. The benefit of this is if we have multiple blocks now, I get to know every single time they're changed. And that's a really good thing. We can also do this for onTransition. We can also do this for onError, for everything. All right. So you can try this stuff on your own. This is a nice thing to have in your app if you want to keep track of the changes. It helps in debugging a lot. So that's all I had for BLoC and Cubit. Now finally, let's get into the weather app where we implement the BLoC pattern using BLoC state management. So the final app that we're going to work on is the weather app. To continue along with me, you can find the link to the beginner files in the description below. You can clone the repository, and after you run it, it should look something like this. This data that you see, all the data that's present over here is coming from the Open Weather API. So this is the main temperature in London right now. It's coming from the Open Weather API. This is the hourly forecast, and there's additional information about humidity, wind speed, and pressure. To dive into the code, we can open the lib folder, and as we can see, there's only one screen over here, which is the weather screen. This weather screen not only contains the UI, but also the call to the API over here. So everything is set up in just one weather screen file. So it gets the current weather, then we call that get current weather and we display it on the screen. We also extract the data over here in the build function so that we can display it on the screen. There's separate cards created for hourly forecast and additional information, which you can find over here and here. The secrets.dart contains the Open Weather API key, and that's all there is to this app. Now, what is our objective with this? The objective is to convert this messy code into a systematic code using the BLoC architecture. And we'll also be using BLoC state management to do so. To get started, first we must understand what is BLoC architecture overall. This diagram that I have encapsulates this pretty well. First, there is the UI screen. UI screen communicates with the BLoC. How does it communicate? Well, UI screen sends something known as events to the BLoC, and we already know what events are. There are certain inputs that can be given in the UI screen, let's say when a button is clicked or something like that, or even in some lifecycle method, for example in init state. So UI screen sends events to those blocks. The BLoC then communicates with the repository. To understand repository, we must first understand network provider. Repository sends a call to network provider. Now what is this network provider? This network provider is basically your data provider. By data provider, I mean in the weather app, we are communicating with the Open Weather API, right? Now we need that Open Weather API raw data that we have. So network provider is just going to send the call to Open Weather Map API, and based on that, I'm going to get some data, and that data is going to be raw data. So network provider just gets the raw data. Then it sends the raw data to the repository. Once repository gets the raw data, it handles that data. How? It converts the raw data from whatever form it is, let's say a string, to a form which would be a beneficial developer experience. For example, it would convert this entire thing to a weather model in our case. So it basically takes a string and converts it into a model format. And then it sends that model format to BLoC. After BLoC gets that weather model, it just takes that data and sends it to the UI screen. Now in between, there can be errors that occur and BLoC handles that. If there's an error, BLoC will correctly notify it in the UI screen, and if there's no error, then it will display it on the UI screen really well. So that's how the whole flow goes. I'll get back to this diagram after we complete the app, but I hope you get a very basic understanding of what's going on. So first thing that I want to do in terms of code is just take all the widgets and screen and put them in one layer. So one important thing to note is that there are 3 folders that we can create. The first one is the presentation layer. This presentation layer is going to contain everything UI related. It can contain screen, it can contain widgets. It can contain all of these things that are visible to the user. Then we have the BLoC layer, which we can just call it as a BLoC layer. And the third layer that we have is the data layer. Data layer contains everything related to, data, because network provider provides their data from an external API to us, and repository modifies that data, handles that data, and gives it to the BLoC. So both of them fall in the data category. So let's create those folders. The first folder that I have is presentation. And in presentation, I can have screens and I can have widgets. Now, if you're using the feature first approach, that means you're dividing your folders into features. Then you can have, let's say, one feature, and inside that you can have a presentation, BLoC, and data layer of its own. But if you don't know what feature first approach means, don't worry about it. You can just follow along like this. So in this presentation layer, I can pass in my screens. So that should be fine. And it automatically modifies my main.dart file. Now I can take these 2 widgets and put them inside of the widgets folder. And we get an error over here because these 2 imports are incorrect now. To make them correct, we can just remove these 2 imports, go to the bottom, import this hourly forecast item, and also import this additional info item. There we go. Now, if I just restart my app, nothing really changes, but now we've just organized our code a little better. Now, after the presentation layer is done, I want to work on the data layer. I'm skipping BLoC layer for now, but we'll get to it later on. First, let's just manage data. In data, we have 2 parts, repository, which is this part, and the network provider, or I'm just going to call it data provider. So I'm going to create a repository folder, and I'm also going to create a data provider folder. In this data provider folder, I'm going to create weather_data_provider.dart file. And this is going to contain a class called weather_data_provider, and the task is very simple over here. We are going to contain all the CRUD related operations over here. So creating something, reading something, updating and deleting something, everything is going to come over here. And in our case, we only need to fetch the data from an external API. So I can just go to my presentation screens, weather screen, and here I can just find my code for get current weather. I'm not going to rewrite all of this, so I can just Command C and Command V over here. Now I get the current weather from here. But instead of returning map of string comma dynamic, I'm going to return a string. And of course I need to import HTTP because that's the plugin I'm using to get data from an external API. So I can just do import package HTTP http.dart as HTTP. Once we do that, we have HTTP with us, and we're not going to specify the city name over here itself. What we can do is remove it from here and ask it in the parameter. So this is where the city name will come in handy. The next problem is that OpenWeather API key is not defined. So we need to import the secrets.dart file. After we have done this, there's only one error, that is the JSON decode. But as I said, we're not going to convert any data over here. We're just going to go to the API, we're going to call the API, and whatever result we get, we're just going to return that result. So we can just do return result over here. But result would just return a response, so I can do response.body, which would be a string. If you want, you can also do response.bodyBytes, which would return a uint8 list, but I think body should be fine for me. So the task of weather data provider is just to go to the API and return the string. After we've done that, we can go to the repository and create the weather underscore repository.dart file. And again, this is going to be a simple class, which is called weather repository. And here we're going to have a similar function implemented. So I can go to my weather screen, copy this line and paste it over here. But now instead of calling the API again, I'm just going to take this weather data provider and insert it over here. So I can just do weather data provider dot get current weather, and then I need to pass in the city name, which I can mention over here, or I can again take it from the parameter however we want. I'm just going to keep it over here and move on. Another thing is, if you're unit testing this function, you don't want to create instance of weather data provider over here. You want to get it from the constructor. If you don't know about unit testing, you can check out my series on testing as well. But now, considering that you already know what unit test is, I can just take this weather data provider and generate a constructor for it. So I will generate the constructor, and there we go. I'm actually not even going to require this. This is just going to be a positional argument. So once I have the weather data provider, I can use that instance to get the current weather, and based on this, I will just get final weather data is equal to await weather data provider dot get current weather. There we go. But now the function of the weather repository is to modify this data into an understandable format. So I'm going to keep this code, and what I'm going to do is use JSON decode over here. I'll take this weather data, pass it over here, because essentially we are getting response.body, right? We're returning response.body from here. So I can just take this response.body and replace it with weather data. And then I can just check if data at this is not equal to 200, then we'll throw an unexpected error occurred. But if that's not the case, if the status is 200, then we do not want to return data because that's just dynamic, and we know it's going to return map of string comma dynamic. I don't want to return that. What I do want to return is a weather model. So I'm going to create my weather model first. So in the lib folder, I'll create a new folder called models, and here I can create weather underscore model.dart file. And then I can create weather model class. But now what are the arguments of this weather model going to be? To get that, we can go to weather screen where we have extracted all of our data, right? I can just copy all of this, go to weather model and paste that in. So this is all the data that I need to convert basically. So now that we have all the arguments with us, we can just go ahead and put them in. So we will have final double current temperature, because the current temperature is a double value, then final string current sky, followed by final double current pressure, and rest of the things are going to be double as well. So I'll quickly write them up and I'll see you after I've written them. Alright, now that this is done, I can just generate a data class for it, right? So I'll just generate a data class based on the Dart data class generator extension, and there we go. Now I can just copy all of these things and paste it inside the from map function so that I can convert the data very quickly. So for current temperature, it needs to get this value. For current sky, it needs to get this value from the API. All of this was done in the Flutter beginners tutorial if you're interested in it. So we can uncomment current weather data, put it as map, and then take each of these values. So I'll just take current weather data mean temperature and put it over here. The same thing for current sky. Then the same thing for current weather data pressure. the same thing for the speed, and the same thing for humidity. Now that we've done this, we can just remove it and save this. Awesome. Now that weather model is created, I can close this and go back to the weather repository. Now, instead of returning map string dynamic, I'm going to return a weather model, right? And now I have access to the weather data, which is a string. So I do return weather model dot from JSON, and then I'll pass the weather data over here. Alternatively, you could also do from map and then pass the data over here, and it would work fine. And if you were confused about what's happening over here, basically I created multiple functions like toMap, from map, and all of those things, but the main part is just the for map for us, from map, sorry. What we're doing here is we're taking in the map and we're just extracting data out of that map and returning a weather model. From a map, we're creating a weather model. That's all that's happening. So yep, that's how we do it. We're throwing an error in case it occurs, and then we're returning a weather model if it's all good. So I hope you've also understood the difference between the network provider and the repository. In network provider, we just went to the API and got the raw data, and in repository, we are just taking the raw data and converting it into a weather model. And that weather model will be accessible in the block. That's what we are returning. Now from this repository, we're going to go to BLoC. So let's create a BLoC over here. In the lib folder, we're going to create another one, which is going to be a BLoC. So as we know, to create a BLoC, we can just do Command-Shift-P, new BLoC, and after that we can write weather as the name of the BLoC. Then we need to select a location, and the location is going to be in the lib folder only. So I can select that folder, and there we go. BLoC has been created. But one thing we forgot to do is add the Flutter Bloc package. So let's add that dependency, Flutter_Bloc. After that is done, we can remove these two imports, import the Flutter Bloc library, and we also need to import the foundations .dart line. All right. This came from the immutable, so we had to import that as well. Awesome. Now let's start configuring our weather state. So weather initial is already created for us, and I'm going to keep that because, as I mentioned in the login app as well, weather initial is going to be the initial state. There's no success, there's no failure. And the rest of the three states are also going to be very similar. It's going to be final class weather success, and that's going to extend the weather state. Then we are going to have final class weather failure, and that's going to extend the weather state as well. And then we have the final class, which is the weather loading, which will be extending the weather state as well. So we have created all of our states, and that's good. Now we can go to the weather event to create one weather event that we have. And the one weather event we have is just to fetch the weather data. So we can just say final class weather fetched, because remember I told you that the weather event should be in past tense. So we can just extend that to the weather event. As simple as it gets. So that's the one and only event that we're going to have right now in our app. If you decide to expand this app further, you'll have more events, obviously. Now we can go to the weather block layer, and here we're going to listen to one event, and the event is going to be, well, weather fetched. On weather fetched, we're going to get event and emit, but we're going to create a separate function for them. So we're going to have void get current weather. Then we get access to weather fetched event and emitter weather state, and that's how our function looks. So now I can just pass this get current weather, and it should be a private one, otherwise it will be accessible outside the block, and we do not want that generally. Awesome. Now that we have the get current weather created, what are we going to do in this block? As I said, this block is going to communicate with this repository. They both are going to be in contact with each other. So that means we're going to call the repository in the block itself. And again, if you want to unit test your block, you want the weather repository to come from the parameter or the constructor of the class. So we can ask for weather repository from the constructor now. And this would be this dot weather repository. There we go. And now we can call the weather repository dot get current weather. Nice. Now this can be async as well. We can await this and we would get a final weather, which would be equal to the nice weather model that we have. And since this get current weather can throw, we always want to use try and catch block in the block as well. So we can just go to weather block and here have try, take this, paste it inside, catch, E, and then I can emit if there's a failure. So if there's a failure, I'll just do weather failure, but it doesn't accept any argument, does it? So I can just go to the weather failure class, just as before. We're just going to have final string error. Then we're going to create a constructor based on this. So we'll create a constructor and then emit the weather failure. And I don't want this to be a required argument, so I can just convert this to a positional one. And now I can pass e.toString over here. Then we get the current weather, and if everything goes well, then we want to emit weather success. But just doing weather success isn't enough. We want to display the weather as well. That's why in this weather success, we're going to ask for the weather model. So whenever there's a weather success, I want to get the weather model. So we have final weather model, and then we can click on the bulb icon and create constructor for it. And then here I can pass my weather model in. So I know I rushed this part a little bit, but just to explain it again, whenever we fetch the weather, this get current weather function will get called, and this gives us access to the event and the emit function. Then we start the try catch block, and then here we say that we want to get the current weather. So it would be from the weather repository, which would give us access to the weather model. Once we get the weather model, we are just saying that I want to emit weather success with the weather model passed to it so that I can display it on the screen. However, if any error occurs, then I can catch it and then emit a weather failure passing an e.toString. And one thing we forgot to do was emit the weather loading event, because as soon as get current weather gets called, I want to make sure that we start loading the indicator, and then if there's a success or a failure, we're just emitting, so it's fine. So that's the entire thing for our blocks. We can close all the save files. I hope you've understood it. Now we can just go to the presentation layer and start removing all the unnecessary stuff. So for example, we don't need this part. We don't need to call get current weather. We don't need the weather future. Instead, over here, we're going to use BlocProvider to call this particular event, the weather fetched event. So for that, first I need to register my block as well. So to register the block, I can just go to Material app and then wrap it with a widget called BlocProvider. And here, I'm just going to call it weather block. So make sure we import Flutter Bloc and the weather block file. After this, we need to pass in weather repository. To pass in a weather repository, you might think we can just do this, but there's a better way that BLoC provides to us, and that is if we just wrap BlocProvider with another widget BLoC provides us with, which is RepositoryProvider. So we can use RepositoryProvider, which has a very similar layout as a BlocProvider, but instead of returning blocks, we need to provide repositories over here. So we can just use create, context, and then we can pass in the weather repository. Now weather repository requires weather data provider, so we can just pass the weather data provider over here. And now I can just use the instance of this weather repository in my weather block. To do that, I can do context.read and then use weather repository like this. So what I've done is above the BLoC provider, I've created repository provider, something that BLoC provides. And here we can return repository related classes. If you have multiple repository, you can always use multi-repository provider, which is also provided by BLoC. And in the child of this repository provider, we have the BlocProvider, where we are returning a weather block and doing context.read weather repository. So we get access to this particular instance of weather repository. Nice. Now I can just go to the weather screen and use context.read, which comes from the Flutter Bloc library. And here I can pass in weather block. Then I'll use .add to add an event, and my event is weather fetched. All right, there we go. So in the init state, as soon as we start the app, we'd use context.read.add weather fetched to get the weather. And as soon as we add this weather fetched event, a weather block will run and it will catch this and it will start executing this function. And as we know, this would go to the repository would go to network provider, and everything would happen. Now we can remove the non-essential functions. I can just comment this out. We'll not be using future builder anymore because we don't have a future to handle anymore. We've already done that in weather block. We've already got our data and all we need to do is display that data. So instead of future builder, I'll have BlocBuilder. Then obviously in the BlocBuilder, I need to mention the name of the block, which is the weather block, and the state of the block, which is the weather state. And in the builder, we're going to get a state, not a snapshot. And since this is not a snapshot, it's a state, I can just comment this line. I can also comment this line. And then we have all of these variables. We're going to keep these variables, but we're going to extract the data from this state. But before that, we have to handle the loading state, right? If there's a loading state, we don't have any data. So even if we do anything, it would just give us errors. So here we can just check if state is not weather success. So if it's not a success, then I just want to keep loading forever. So I can just take this and paste it over here. Now I can remove all of these lines. I don't care about them anymore. So if state is not a weather success, it would keep on displaying the loading indicator. But what if there's a failure, right? I still want to display the error text. So for that, we can just handle that case. So if state is weather failure, then I want to return a constant center child text saying state.error. And it's not a constant because we are using state. So we can remove that constant. And there we go. Make sure this if statement is before weather success, otherwise it would just keep loading forever because weather failure is not a weather success. So this condition would be true, and as a result of this circular progress indicator would keep on showing up. But anyways, if there's a failure, we show an error. If there is no success, that means it is just loading. So we display a circular progress indicator. Otherwise, it's going to be a success, and that's why I can just extract the data from here. My final data is going to be state.weatherModel, and that correctly analyzes this because we've already checked the condition that it's not a weather success. If it's not a weather success, this would happen. But if it is a weather success, that means we're only going to get the weather model. And that's why we get the weather model. Now we can use that to get all the data. So I can just remove this current weather data. It doesn't actually contain any data for us. Then I can take this data and do data.current temperature. That will give me the temperature. And the same for all of this. I'll do data.current sky, data.current pressure, data.current wind speed, and data.current humidity. And because of this, all the errors over here will not be there. And the final 5 errors are in this hourly forecast. And I'm not going to complete this part. I leave it up to you. If you've understood this till here, you can try it on your own and see if you're able to do it. It's a very similar logic. We've already got the weather data provider with us. We're already getting the weather repository. We're converting it to from map. So we can just pass in the arguments over here and see how to get all the hourly forecast item stuff over here. So I recommend you to try this on your own, but I'm just going to comment this out and see if the block layer worked successfully for the rest of the things. Let's also remove the unused imports. At the end, we can see if it worked. So let's get it. And we do see the temperature over here with all the additional information. If we try to run this, this doesn't work because I commented this part over here. So let's implement this as well. So whenever this refresh icon is well run, I just want to call the API again. So I can just take this and paste it over here. And now if I run this, you see, I see the loading indicator once. That's good. Now just to verify that everything works properly, I'm going to go to the weather repository, and instead of London, I'm going to put New Delhi and see if that works. So I'll just restart, and there we go. We see 291 with everything correct as it should be. And this is the weather app implemented using the block layer. Now just to get everything in place, I'm going to explain this BLoC pattern using our current code. So I'm just going to start from the ending. First, we implemented the network provider, which was our data provider over here, and we got the current weather. It was in the raw data format. It was in a string format. We didn't manipulate the data in any way. We got the data from an external API. We just took the string part of it and returned it to repository. So repository got a raw data. Now what repository is going to do is convert that raw data into a data that would be helpful to us. And we did that by creating a weather model. Once we created the weather model, we called the weather model.fromMap function, because of which we were able to return the weather model to our block layer. Now the data that we would return could also be map of string, dynamic, and that would be fine as well. But I think weather model is a better way of doing this because we get auto suggestions when and wherever we need. So it would be less error prone and would result in a better code quality overall. If there's an error, it also throws an error. So if it throws an error, that also goes to the block, and the block can then display it on the UI screen. For example, if I go to weather repository and actually weather data provider and mess up the URL a little bit, let's see. I'll restart and you see it shows an unexpected error occurred. And this shows up because in the weather repository, we're throwing an error if the status code is not 200. So it shows this error message. And that's what we were returning to our block. And we know what block is. Finally, I can tell you what block means. Block basically means business logic component. So block is basically managing all the business logic of our app. In block, we basically send the input. So UI screen is sending an input to a block, right? It is from the init state of our UI screen. We are saying that as soon as the screen loads, we want to send some data or some input to a block. And that input is an event. Based on this event, we will get data from the repository. And the repository would get it from network provider, then it would manipulate the data, it would send it back to block, and now again block is managing what should be displayed on the screen. So it's managing the entire business related logic of our app. It decides when to show the loading indicator, it decides when it is a success or when it is a failure. And the UI screen at the end is displaying everything. It is displaying the widgets, it's displaying the screens, it is displaying the entire layout. But block is the one that is deciding what to show. So I hope you've understood this entire BLoC pattern. And I also hope you've understood things about BLoC and Cubit. I've not used Cubit in this one because I thought let's just use a complex example so that people following in Cubit would also be able to follow. Now I understand some of you might think why we gotta put our code through so many layers. It's just making a simple app more complex. And you're right, it does make a simple app look more complex. But what if the simple app became complex? The app starts to become complex when more features and more engineers start working on it. What BLoC offers is separation of concerns, testability, and scalability. By separation of layers, I mean every layer has a well-defined unique purpose and all of them do not interact with each other. For example, BLoC can interact with the repository layer, it cannot interact with data provider layer. Because of this, we get saved from a big mess the code could potentially become. So this was it for the tutorial. Thank you so much for watching, and I'll see you in the next video.